Welcome back, guys. So this is question number 13 of our book Introductory Circuit Analysis by Robert Boylestad, and here we are given this circuit in which we have this digital multimeter readings for the current and for the peak to peak voltage as well. With this peak to peak voltage is basically calculated from the oscilloscope, okay, while this one is calculated via digital multimeter. Okay, so from it what we have to calculate, we have to determine the value of L, which is this one, and also the value of this resistance as well. Okay, so let us proceed here. So part A of our question, we have to find out the value of L, and we know very well that to find L, let me have the expression for V of L, and for V of L I know that V of L is I x of L. Okay, this is equation A, and also from x of L we know that x of L is omega L. Okay, this is equation B, and here omega is equal to the 2 pi f. This is equation C. Okay, so now in order to proceed here, let me first find my quantities here. So this one, the total voltage here or the source voltage here is basically in RMS, the current is in RMS, while the value of the voltage here is basically the peak to peak voltage. Okay, so I have recently covered that how this peak to peak voltage seems like. So let me have it, this V peak to peak, and that is 21.28 volts. So now in order to find the Vp in the symmetrical waveform, what we have to do, we have to 21.28 divide it over this two. So what I will get here, let me use the calculator here. So here 21.28 divided by 2, so it will be 10.64. so this is 10.64 volts, while this one is the peak voltage. I know previously that Vrms is equal to the Vp divided by square root of 2. So let me use the same procedure here. So 10.64 divided by square root of 2, how much would it be? So dividing it over square root of 2, I will get 7.5 volts. Okay, so writing it here, 7.5 volts. This is the RMS value of V of L. So this is V of L. Okay, so I know the value of V of L. I have the value of current here, which is same here, because this is a series circuit which is consist of these two elements. So this equation satisfies, but how to find the value of omega? So let me start it from C here. So let me write values here. So 2 pi, and the value of f is also given here, that is the source frequency, and that is 1000 hertz. Okay, so writing it, 1000 multiplied by 2 is 2000, 2000 multiplied by pi is how much? 2000 multiplied by 3.14, and that would be 6280. So that is 6280 radians per second. Okay, now taking it from here, okay, and putting it here. Okay, when I will put it here, what I will get here, I will get here the value of x of L will be 6280 multiplied by L. Okay, so this is the expression for x of L. Now taking this one, okay, and putting it over here. Okay, so now let me use it. Okay, so V of L is I x of L. Putting the value of x of L, what I will get, VL is equal to the I multiplied by 6280 6.80 multiplied by L, okay, or the value of L here is how much? L is VL divided by I into 6280. Do I know the value of V of L? Yes, it is known, and that is 7.5. Do I know the value of I? Yes, this is also known, and this is the 29.94 milliamperes. So 29.94 milliamps, which is 10 to the power minus 3, and that is here 6280. Okay, so now let me simplify it. So 7.5 divided by how much? So let me use this expression as a denominator of this equation. So 6280 multiplied by 29.94. okay, so this would be this one, and dividing it over 1000, because this is 10 to the power minus 3. So how much it would be? It would be 188. Okay, this is almost 188. Okay, so now simplifying this one again. So 7.5 divided by 188, this is 0.0398, 0.0399. okay, so this is the value of the inductor, or if you want to find it in the millihenry, so in millihenry it would be 39.9 millihenry. So that is the value of the inductance which we had to find out. Okay, so through this procedure we have found out all these values. Okay, so that is the part A of our question. So in order to proceed, what we have to find out, we also have to find out the value of resistance here as well. So now to find out the value of this resistance here, what we have to do, we know that with every element we have three quantities associated. What are those quantities? The current, the resistance or impedance, or the voltage. Okay, so these are the three quantities. I have previously stated that if any of the two quantities are known, we can very easily find out the third quantity as well. Okay, so we know the current here, but we don't know the voltage here. Okay, so let me first find the voltage here in part B. So in our question here, we can very easily see that here the phasor sum of total voltages across elements is equal to the source voltage. Okay, here we have these two elements, inductor, resistor, and then this source voltage here. So the phasor sum of the voltage which is consumed across this resistor and the inductor here is equal to the source voltage. Okay, so how to use this equation here? So now here we can see that E is equal to the phasor sum of VR and VL. Okay, so this is basically the phasor sum. Why am I using the phasor terminology or phasor summation over and over again? Because here we can see that resistor is basically the real quantity, and in resistor we have, this will be the voltage. Okay, because no phase shift can occur. But when we consider this V of L, we will see that V of L is equal to the I j x of L, which is I multiplied by x of L with an angle of 90 degrees. Okay, so this j is basically corresponds to this 90 degrees, therefore it will lie here, at positive axis. So it will be x of L and it will make this angle here. So these are basically the quantities, and to find the value of E, what would we found out here, we will see that it will be somehow like this. This is V of L. So now in order to find it out, let me plot their values. So here this will be VR, okay, this will be VL, and the source voltage will be here. So this is here, okay. So here what we have to find out, we have to find out the value of V of R. So therefore in this, let me use the Pythagorean theorem. So according to that, E is equal to the VR square plus VL square, so that is equal to E square. So now in order to find the value of VR, VR will be equal to the E square minus VL square whole square root. So let me use these values here. Do I know the value of E? Yes, it is also known, and it is 10 volts. So 10 square minus what is the value of V of L. So the value of VL is also known, and that is 7.5. 7.5 whole square root. Okay, so let me use calculator here. So 10 square minus 7.5 square, it will be 43.75, and square root of 43.75. so let me 43.75, this is V of R, or the value of V of R will be equal to how much? Square root of 43.75, it will be 6.61. So this is 6.6 volt. So the value of VR is 6.6. Okay. Now to find the value of resistor, here let me use the Ohm's law. So V of R is equal to the I multiplied by R, or the value of resistance is VR divided by I. I know the value of V of R, that is 6.6, and the value of current is how much? It is already mentioned here, and that is 29.94 milliamps. 29.94 into 10 to the power minus 3. So it will be 6.6 divided by 29.94 into 10 to the power 3. Okay, so let me calculate it. 6.6 divided by 29.94, so it would be 0.220. So 0.220 to 10 to the power 3, or ultimately I will get here 220 ohm, because this is 1000 multiplied by 0.220 is 220 ohm. Okay, so that is the value of resistance. So in this question we have found out how to use the values calculated from the oscilloscope and digital multimeter to find the values of the unknown quantities which are available in our circuit. Okay, this is somehow like a practical example in which in many scenarios, in many circuits, we don't know the internal configuration of any circuit, or inside the black box we don't know the quantities available. So at the output of our system we can connect the oscilloscope, digital multimeters, and can very easily find out the internal configuration of our circuit. Okay, so that's it for today, and with some more interesting questions I will see you in our upcoming video. Thank you so much. See you soon.